Hello, Pre-Calc. I am on page 12 today. I'm going to do page 12 and 13. This is power rule and definition of derivative. So, if you see, you just kind of glance at the page and you see these limit problems. Well, you can go through and do all the algebra needed to find the limit, add x equals 3 in the first one, or just go through and find the limit of that in the second one. Or you can recognize that this, let me get my highlighter, this is the definition of derivative. So, a function is plugged into the definition of derivative in all of these. So if I'm recognizing this as just not another limit problem, if I can figure out limit as h approaches 0, and then I kind of notice like, that looks like the definition of derivative. I see an x plus h. I mean, that's a giveaway right there, minus something. If I notice that, then I don't have to go through all the algebra. Here's what I can do. I can say, okay, I basically just talked about the first part up here. Recognize that something's plugged into the definition of derivative. Find the function. Well, we did this, I'm going to say a couple days ago, whatever, it was a couple lessons ago, where we find the function that was used. So what function was plugged into definition of derivative in the first one? X squared. Now, I want the derivative at x equals 3. That does not mean I'm going to take 3 and plug it in there and get 9. Of course, that's a choice. But what I need to do is recognize that it would be the derivative at 3. So then I have to take the derivative and then plug the value into the derivative. So f prime of 3 is going to give me 6. Oh, I was getting ahead of myself. Okay. All right, let me do another one before I pause it and kind of have you guys try them on your own. So in the second one, I'm finding the function that was plugged into the definition of derivative. The function that was plugged into the definition of derivative here was 2x to the 5th minus 5x cubed. Now, we've been making a big deal about the fact that you call this f of x, because this is not the thing that I'm talking about. That's not my answer. I'm surprised that wasn't a choice, to be honest. That's just finding the function. Okay? If I think I said in my last video, like the video where we did this, I think I said I like using this part because I don't have to play around with the signs. It's just like 2, and then wherever I see an x plus h, that's an x. So 2x to the 5th minus 5x cubed. If you grab this and think this is the function, you're going to have your signs messed up because the negative was already distributed through. Okay, so the answer to this, they're not giving me a value to plug in. The answer to this is the derivative of that function. So I have to go through and take a derivative. And now that we know how to do the power rule, this should be pretty easy. So 10x to the 4th minus 15x squared is the derivative of that. Okay, I'm going to pause it and I'm going to do the next 2 on this page. So you guys should be pausing it, do the next 2, and then we'll take a look at the answers. Okay, so you can see for number 3 I got B. This one was pretty much like the first one. F of x is x cubed. Derivative is 3x squared. Plug 2 into the derivative to get 12. The second one doesn't specifically say 2, but you can see that there's a 2 plugged in. So when I find the function, it's f of x equals x to the 4th. You can see that over here. And then I take the derivative, and then I plug 2 into the derivative to get 32. If we did this limit out, doing all the algebra, we would end up getting 32. Okay, I'm on the next page, and I'll go through these. Okay, so finding the function. This one doesn't have a number to plug in, so I have to find the function. And again, I like looking at the first part, so I'm looking at 3x to the 4th minus 4x squared plus x. Everywhere I see an x plus h, I'm just putting an x. And then after that subtraction, that matches with a negative. If a negative was distributed through here, I would get negative 3x to the fourth plus 4x squared minus x. So that is looking good. That is not going to be my answer. My answer is going to be the derivative of that, because that's what this is, the definition of derivative. So now we already know how to do the power rule. 12x to the third minus 8x plus 1. That's what we're going to get for the derivative. I am seeing which choice that is. That is choice 1, or A, sorry. The next one, I'm just going to run through these. They're pretty quick. The function that we're talking about is x to the fifth. The derivative of that is 5x to the fourth. I want the derivative at negative 1. Negative 1 to the fourth is just a positive 1, so this is just going to be plain old 5. Okay, now we're going to get into some of those other derivatives that we were talking about. Hopefully you were watching that video and then tried the homework on your own, because the homework calls up these derivatives just to say, like, hey, you have to start getting used to them. So in number 7, the function is cosine x. You are not plugging into that. You are taking the derivative of that. The derivative of cosine x is negative sine . And then I will plug the pi over 2 into that. Now you know you wouldn't be allowed to use a calculator for that, so let me go through that process. Pi over 2 is up here. That point is 0, 1, so the sine of it is the y value, so that'd be 1. There's a negative out front, so this answer would be negative 1. Okay. The next one. Just erase some of this stuff over here. Okay, the next one, the function is ln of x. The derivative of ln of x is okay, function ln of x, derivative is 1 over x. I want the derivative at 5. Oops, forgot my prime there. Hello, bad mistake. 1 over 5. The next one, we change colors here. We'll go to blue. Function is tangent x. We need to know the derivative of that. It's secant squared x. Now I'll plug pi into that. Well, how am I going to figure out secant squared of pi? Well, if I know what cosine of pi is, then I'm just looking for the reciprocal. So pi's over here. That point is negative 1, 0, so the cosine's the x value. So I'll change this to 1 over cosine squared pi. I'm just so good at writing on this thing. So this is 1 over negative 1 squared. Well, that's just going to be 1. See how 180 is a choice, just to really throw people off there? Okay, last one. Derivative, the function that we're looking at in the last one is e to the x. The derivative, like I was saying in the last video, is pretty unique in that it's itself. So the derivative of e to the x is e to the x. We want the derivative not at 5. Don't look at that too close, too fast. We want the derivative at ln of 5. Oh, I love this question. How come? Oh, I wish we were still in school. This would be so fun because we did this 700,000 million times. And I would be standing there waiting for somebody to tell me, how come that is that? And somebody would absolutely say, because they're inverses. Because e to the x and ln of x are inverse functions. So plugging a 5 into ln of x and then taking the answer, ln of 5, and plugging it into e to the x, inverses undo each other. So we're back to 5. Okay, so it's just a little bit of review there at the end. All right, so do the homework. This should be another easy week. We had some power rule on Monday with some fractional exponents and all that stuff. Hopefully you did that and checked the answer keys. And hopefully you realize that you need to know those 5 derivatives. And then today was just kind of recapping like, hey, can you pull out the function looking at this? Like, can you say that that function is tangent? And then can you take a derivative of it and then plug in? Okay, same thing up here for our polynomial functions. Can you figure out that the function that we're talking about here is just x to the 5th? Then take a derivative of it, 5x to the 4th, and then plug in. Make sure you take a derivative of the function before you plug in. All right, hope everybody's doing well, and I'll be back with another video next week.